We're going to look at the properties of logarithms. We have the 4 properties listed here. The first one is called the product and product rule, and it takes a sum and can rewrite it as a product. The second one takes a subtraction and rewrites it as a division. And the third one takes something raised to a power, the log of something raised to a power, and allows it to become a multiplier or a coefficient of the log. The fourth one's called the one-to-one property. It allows us to have an equation where 2 logs are equal to each other as long as they have the same base. Then we can basically ignore the logarithms and just look at what we're taking the log of. And so the primary way we use these properties is in condensing and getting expressions with only a single logarithm. So for this first one, we want to get this as an expression with a single logarithm. This would become log base 2 of x plus 3 times x. And so we can actually multiply that, and that's going to give us log base 2 of x squared plus 3x. So we use the multiplication rule, took an addition and turned it into multiplication. The part B, or example B, we're going to do division. So that would be log base 3 of 3x minus 4 over 2x plus 7. We're allowed to do that, so we only have a single logarithm. The third example is using the the power rule, where we can take the 2 and it becomes a multiplier. So that's 2 times log of x plus 7. And remember, this one is log base 10. It's not written in, so we have to know that it's base 10. And D is log base e. Natural log is also called log base e. And again, we're using the quotient rule on this one. And this will be natural log of 14 over x. Okay, these next 3 examples, again, we're using the properties of logarithms. The property that says we can drop the logs, as some people like to say, this is the one-to-one property. The last one, number 4, that says if the 2 logs are equal to each other, then we can just ignore the logs and put the 2 expressions equal to each other. And we're able to solve this. We're not going to solve this today, but it becomes a very simple equation at this point. These last 2 examples use the power rule, where the power that we're taking the log of gets to become part of the multiplier. So this is x plus 3 times log 4. Now remember, this is also base 10, but this is becoming a x plus 3 times log base 10 of 4. Log base 10 of 4 is just a decimal. We could distribute this if we ever needed to, because we're just multiplying x plus 3 times a constant decimal, however it may be. Same with the power rule on this one. We can take the 3x plus 7, and it becomes a multiplier of natural log of e. Now, what you may not know is that the natural log of e means log base e of e, which is asking the question, what exponent turns e into e? And so the answer to this question is 1. And so we learn one of these properties for another video, but the natural log of e is 1. And so really, this whole expression has just been simplified to just 3x plus 7, because natural log of e is 1.